Okay, now we'll be looking at part 2 of the Magnetic Interactions Lab. And this one deals with the force on a current due to a magnetic field. And so what we're going to be doing is holding these magnets, which again, north red, south yellow, near these copper wires to see what happens when we send current through. So for the first one, we have north facing up, so our field is coming up out of the magnet and going up. Our current goes from red to black, so it's going to be flowing away from the camera. And so with our right hand rule, we'll have field up, current away from the camera, and it's going to apply a force on the wire to the right of the video. And so to test that, we'll simply close the switch and send current through. And as you can see, it swings to the right. So I'll steady this and we'll do it one more time. And so field up, current away from the camera, and when we close this, it swings to the right. So now, on part B, there are 5 tests that we're asked to do. The first one is to simply turn the south pole. And so now you think about which way the magnetic field is going, and since field lines go from north to south, we're now going to have a field going into the magnet or down. And so current still flows away from the camera, field goes down, and so field down, current away, it's going to push towards me. And so close the switch, and you can see that it does in fact swing towards me or to the left. So I'll slow that down and then we'll try it one more time. So again, south pole, field going down, current going away from the camera, and I close this and it swings to the left. The next question is what happens if we reverse the poles, or the direction of the current. And so we're going to swap red and black up top. And so now the current is going to flow towards the camera. And so now we have field going up, current going towards the camera. And so the question is, what direction is it going to swing? And so we close the switch, and you will see that it now swings towards me or to the left with the north side of the magnet, which is opposite of what it did when we had the direction of the current reversed. And so this makes sense if you apply your right hand rule. Again, field goes up, current goes towards the camera. It is now going to apply a force towards me or to the left. So I'll stop this from singing and we'll give it one more try. And you can see with north, it swings towards me or to the left. And now we're going to try with the south pole of the magnet. And as you might expect, it is going to swing to the right or away from me. And so one more time, holding the south pole of the magnet close, and it swings to the right or away from me. So now we're going to swap these back to the way they were, and so current is now again going away from the camera. So now, what happens if we hold the magnet close and the switch remains open? As you can see, it does not deflect in either direction, so there is no force, and this makes sense as there is no current. If you try to apply your right hand rule, you can have field going up, but there's no direction for the current to go, so there's no force applied on the wire. Now we're going to test distance to the magnet, and so distance to the magnet is directly related to how strong the field is at that point. So the closer we are, the stronger the field. So we're going to close this with the magnet close, and it swings pretty violently to the right. So I'm going to settle this, and now we're going to hold the magnet a little bit further away, and we're going to close this, and you can see it gently swings to the right now. So lower magnetic field strength, lower force. And the last one is we're going to hold the magnet parallel. And this one's a little bit tricky. So I have north towards the camera and south away. And this creates a weird scenario as our field, if you remember from the field of a single bar magnet, actually goes up out of the north end and back into the south end. So nearer to the camera, we have a field going up, but further from the camera, we actually have a field going down. And so close to the camera, if you remember your right-hand rule, we have field going up, current going away from the camera. It's going to try to push to the right. But farther from the camera, we have our field going down, current going away, and so it's going to try to push towards the left. And so what we're going to get is a torque on this wire, and it's going to wobble back and forth as it tries to go in both directions. But the further corner is going to try to come towards me to the left, and the closer corner is going to try to go away towards the right. And so let's hold the magnet close and close the switch, and let's see what happens. And as you can see, it starts to rotate a little bit. So I'm going to steady this, and we're going to do it again. And just pay attention to the front end and the back end and see how it twists to try to follow both directions of force. So that's it for part 2 of part 2. Please move on to the next video to observe part 3 and see what happens in regards to the field created by the current itself.